All right, folks, this is our first slide of the day. Here we go. We're talking about AI-guided visual inspection today for this webinar. I'm your host, DJ Singley. I'm the MAPSYS Executive Director of Data Center Solutions. Wow, that is an unbelievable mouthful. Ridiculous. There's my email and phone. You could always ring me up and we can chat more about this anytime. MAPSYS is a company that is owned by all of the employees. We're an ESOP, headquartered out of Columbus, Ohio, serving the entirety of the United States. We have a fully staffed programming arm. We do talent searches, so staffing. We sell software and, of course, hardware for data center solutions. And we're a premier IBM business partner. So all the hardware that goes with that. I, as an aside, love IBM. I used to be an IBM microprocessor designer back in the day, so that's a little bit of my background. I could talk about that all day long, but I won't because we're talking about AI today. MAPSYS, interestingly, also partners with another company called QLX out of Miami, Florida, and we get most of our talent for data science from them. So a lot of times when we work with customers, we'll be bringing in a couple of data scientists from those folks to help us with deployments of visual inspection projects. So what are we talking about today? Let's move on. We're talking about IBM's product, Maximo Visual Inspection. Now, Maximo as a brand within IBM is a sort of a sub-brand that relates to manufacturing and manufacturing processes. Okay, visual inspection is the product, and this product has gone by several names over the past few years, which is kind of funny. Some folks on the phone may remember it as Power AI Vision. That is not a name we use anymore, and then it went into Visual Inspector, and then it went into Maximo Visual Inspection. Not Visual Inspector, Visual Insights, and then it went to Maximo Visual Inspection. So it's finally landed where it probably should have landed all along in IBM. It's an amazing product based on all open source stuff. Open source AI frameworks, open source programming languages, everything. In fact, everything I show you today, you folks on the phone could do with open source software. All of it for free. Yep, you could. The problem with that is you're going to be pulling your hair out and you're going to be working on it for years because that's the thing with open source, right? Is you're going to be carrying and feeding for this particular product or your whatever solution you're designing rather. So visual inspection is going to take that headache you have and your time to market, time to value, and drastically alter that. So let's go over how and why. All right. First thing let's talk about real quickly is where you're going to use this type of software. We're specifically targeting several areas. The first one probably is the biggest one where a lot of you folks are out tuned in today, right, is modernizing your manufacturing and assembly plants. And the biggest part about modernization of these plants is to detect and correct defects before they get out into the field. Right? You want to reduce the manual inspections, which is the worker inspections that folks are doing on the line to ensure quality. Right? Each worker has a different level of competence and may detect different anomalies or whatnot in the product. But we want to go farther than just detecting. We want to provide actionable results on the manufacturing line immediately after a defect is detected so it can be corrected. So again, save a lot of money and time correcting it after it comes out of the widget factory, so to speak. Okay, but this isn't the only place to use this product. You could use this product as far as you can. Here's an interesting one that's been done several times already, is modernizing utility maintenance. So think of transmission lines or oil pipelines or whatnot, and high-speed, very capable 4K drones zooming by these lines, taking pictures or video and feeding it into a system like this. Well, it's almost impossible for a human to look at tens of thousands of miles of pipeline or transmission line. But for a computer and AI system, it's not a problem at all. So another use case. But it can go beyond that, right, to more pedestrian examples like a power generation plant. Again, using cameras and sensors and drones even to inspect the facility and looking for anything that could take the facility offline before it does so. So again, a very good one. The last example, again, a little bit of a pedestrian example, bridge inspection, right? For you folks out there that have certain stationary responsibilities for stationary assets like a bridge, this could be another great way to save man hours and man time doing your inspections, right? How much better would it be to use a drone or a series of cameras and sensors to monitor this facility? I don't have any examples on the next one that I want to just touch on, and that is the medical field. Qualx, our partner, has done a lot in the medical field using this software to identify melanomas and other ailments for that space. So you could certainly use it there, and it does a great job in that area as well. So before we get going into what this product can do and how it looks and how you actually interact with it, let's talk about all of the business benefits for this. And this is important for the folks on the phone that need to report to the people in their business that hold the purse strings, right? And that need to understand the ROI. This is very important. So a few things here. Probably the number one reason to look at a product like this is the manual inspection costs of looking for defects on your assembly lines, right? It's not cheap to have an experienced worker on the assembly line looking for these defects. Additionally, depending on who is on the assembly line, you may get a difference in quality and understanding of defects. So that could also play a very large role in your variances that you're looking at. There's also a high cost of remedy. So when a defect comes off the assembly line, I'm not telling you, the folks on the phone here, anything different, right? When a defect comes off the assembly line, it takes quite a bit of dollars and time to fix. If you could fix it right on the assembly line, you'd avoid all of that cost. And again, everything on these assembly lines, I think, in a lot of places that we go, folks are very slow to react to change, right? They don't like change. The workers on the assembly line, they don't like it. But this will certainly help, I think, them on their daily basis and their daily tasks. The other thing I want to mention too here is that there is no vendor lock-in in our products. Okay, all the stuff, as I've said before, are based on open source technologies. You could do all this by yourself if you wanted to. With open source technologies, it just would take you an awful long time. So let's take a look at the exact benefits here and the value that we can create. First one being point-and-click model building. No need to know anything about AI models or frameworks or anything like that, or programming. Process automation, very important to automate an entire process from start to beginning. You can scale this entire solution. And then, of course, get real-time quality assurance, or what we call error proofing, feedback on the line. And then lastly, the Maximo integration, which we won't talk to very much, but I will hit on it a bit. So let's talk about each one of these briefly. One of the very most amazing things I think about this product is the fact that you do not need to know anything about TensorFlow and PyTorch and scikit-learn and all these fancy AI frameworks. It's all baked into the product. You don't need to know anything about them. Not really. You don't need to program very much or at all. And you don't need to have that domain knowledge of AI in order to use this and be successful using it. Why? Well, because I can train models by taking folks with domain knowledge, so a worker on the line that looks at these failure modes and these defects day in and day out and really understands them, almost from a gut perspective, right? I can take them off the line and I can sit them in the chair in front of this product, and then I can say, hey, listen, you're going to train my model. And all you need to do is click a mouse a couple times and look at pictures or video to train this model. So I could literally suck the domain knowledge out of their head and into a model and continually do that over weeks, months, years. So that is an unbelievable concept. Just think of that for just a second. Unbelievable concept. All of these folks who have this domain knowledge can be sort of combined together in a single model to look for these defects. So it's a really good efficiency, and it's a really strong concept to understand. Moving on. Process automation, right? So we want to reduce the manual inspection process. We want to deliver higher quality, more consistent results as we automate this throughout the assembly line. And all workflows on the assembly line could eventually include AI and AI inspection. I'll show you a little bit more as we get farther along in this presentation what this might look like. But it's very important. If you don't automate these processes, if they're just one-off AI inspections, that's not as valuable as it could be if it was completely integrated. AI-powered insights at scale. If you can't scale this thing from a proof of concept to a fully fledged operating AI in inspection AI in the entirety of the manufacturing plant, you're just dead in the water. Why did you even bother doing it? So this product can certainly scale, and it scales very nicely. It does require some horsepower when you're getting up there on your inspections, but that can certainly be purchased and implemented. We have lots of options for that too. We could do that in the cloud or on premise. Although I will say most folks choose to do it on premise. It's quite a bit of data looking at these pictures and videos. So very important. We'll talk more about this in a little bit. And then the real-time quality assurance, or the error proofing, right? This is when we stop the defects before they make it out into the greater population or into a customer hands. We can stop them, we can correct them before it takes a lot more money, resources, and time to correct them out in the field. Reduce rework and whatnot. Additionally, we can provide feedback to workers on the line as to exactly what the AI has found that needs remedying. And there's a very easy way of doing this, and I will show this to you in a little bit. Okay, so I know a lot of you out there are probably thinking this is going to be very complicated. I have to know about cameras and all this stuff, and just calm down. It's really not. I have lots of really great solutions for you that are not expensive. So let's keep on moving on. Okay, and lastly, visual inspection integration. So the product can completely integrate with those customers out there who already have additional products in the Maximo family. I won't really touch on that very much right now, but it's all there. This is the path to value for your quality inspections on your assembly line, right? Stopping defects at the point of installation, you could save thousands of dollars daily, and we've seen that with customers. You'll be able to quickly react to change. So if something needs to be corrected, we can correct it, get it going back in the assembly line. We can reduce those manual inspections. I wouldn't say eliminate them for sure, but you certainly can reduce them quite a bit and improve the quality of all of those inspections for sure. And then finally, the quality of your entire assembly line goes up, which really reduce costs. We can reduce a lot of costs, maybe by millions or many more than that too. So that's your ROI for a visual inspection. And this is all measured in weeks and months. This is not measured in years. This is a very fast process to identify value and to extract that value in your assembly lines. Let's see a couple of case studies here. Okay. First one, large automotive company. Hopefully you can't tell which one it is by that picture. I don't think you can. So there was a certain part in the assembly line where a part was being manufactured and put together. And on a weekly basis, I think they were coming up with something like 30 defects a week, which then needed to be corrected out in the field. So that means that on dealer lots or in customer hands at great expense. They would find these defects just by putting in a proof of concept on this visual inspection, which would then save all that rework in the field and in customer hands, saving lots of cash, that's for sure. But going one step further is when the visual inspection was made, the workers were able to see that feedback immediately on a screen in front of them. And again, I'll show you how to do that in a very, very cost-effective, easy way of doing it using iPads. And then they can take the corrective actions. So Maximo Visual Inspection was used for this particular project. They're avoiding even more defects now per day, and they estimate about a $1.8 million savings a month. So very, very impressive and important, I think. So we even put in there the use of the iOS devices helps the clients. And it does. You have lots of options to put in cameras and visual parts in these solutions. And an iPad or iOS device is a great, cheap way of doing it. And I especially like it because it provides feedback with that screen to a worker if they're looking for that. This next example is something that's very near and dear to my heart from my younger years when I was a designer with IBM. And that is the IBM systems assembly line. So there you see a few workers putting together a very large IBM system. That might be a DS8 storage array or a mainframe or a large power system, something like that. It looks like it's probably a mainframe if I were to guess. So as these systems become much, much more technically complex, it's harder for these assembly line workers to understand the defects and the failure modes and the defect modes that they could be looking at. So the manual inspection is much, much more difficult in these particular cases. So a AI visual inspection would be very, very cost effective and useful in these types of areas. So again, the solution, Maximo Visual Inspection, of course. Of course, it's probably easier to pay for when you're IBM and you already you already create the software and all the hardware that it's running on too, by the way. So these folks here, these technicians, sat down and actually trained the models with their domain knowledge of what they're looking for. And not just one gentleman or lady did this, all of them did this. So the model now captures all of their domain knowledge of what they're looking for. So it really helps them check and correct any defects that they find. Okay, the business value was very, very clear and came off. It was just a rousing success, right? Very easy to understand where the defects were. Very easy to correct them before they go out the door, or even before these machines go into final manufacturing test. Because all these bigger machines, they do that, and it's just a pain when they go. Look at that thing. It's like a 3,000-pound machine. When that thing goes into final test and it's not working, it takes some very skilled folks a lot of time to figure out where the problem is. Okay, so that's important. Let's take a look at the next one. All right, now let's talk about workflow with visual inspections. Here's a real simplistic diagram of a workflow, and really important to go through it. On the left-hand side, you're going to see an iOS device and local storage. So this is where we gather the data. It can be from cameras, an iOS device. It's going to be stored on local storage, or somehow it gets to some storage somewhere. All right, via camera, Raspberry Pi, what have you. We're going to then ingest the data into the tool. We're going to ingest it, categorize it, and then we're able to do business value with it, right? And the business value is the three things here in the middle: the label, train, and infer. After we get that done, which is the main part of this tool, then we can do interesting things with it to drive value, right? First thing is batch processing, or we could then export the models via an API, and we can then put them on edge devices like the Maximo Visual Inspection mobile app for iPhone, and or Raspberry Pis or other servers that are connected to cameras for edge computing. But it goes much farther than that. Sometimes edge computing is not good. It is not powerful enough to do the inferences. And an inference just means using your model, right? Just to ask it a question, you get an answer. That's what an inference is. So sometimes we can't do the visual inspection on an edge device, and therefore we can use API calls back to the Maximo Visual Inspection server to do the inspection on a big beefy box, basically, right? There's plenty of applications that just we need that type of a power. So let's take a look at each one. Ingest. How do you ingest? Here's the ingestion process, right? Very simple. Within the tool, you can drag and drop video and picture files into the GUI. All HTML5 based, real simple, real easy. Supports a variety of formats, JPEG, PNG, MP4, etc. And it gives you a sophisticated dashboard. It gives you a dashboard that's very easy to understand with lots of options to customize how you view and look at the data. That's what that means. I'll show you what that actually looks like later. Time to label the data. This is where we take those domain knowledge workers and we sit them down and we ask them to, hey, start giving us your knowledge on what these defects look like, or whatever it is you're looking at or trying to make a model for looks like. And they can very simply point and click and label devices, or rather label objects in a photo or video or whatnot, and continue to do that through this GUI. All HTML5 base. You just point, click. If you can look at a picture and move a mouse, you can do this, I promise you. It goes further than just labeling. We can then augment these pictures that they label by transposing them and flipping them and blurring them and add sepia colors and black and white and all sorts of things like that. And what that does is it augments the data, the possible data that the model could see, because let's just say the camera lens isn't always clean, right? And to continue to keep the model accuracy high. And then I think, which is an unbelievably useful technique, is using auto labeling. We can partially train a model then, and then if we have a very large data set, say 10,000 images, we partially train a model on maybe 100 images, or maybe more actually. And then we use that to auto label the rest of the images in our data set. And then we have those domain knowledge workers go in and check how the auto label did and correct it. And then we can build a model that'll be much more accurate. So all this is very important when creating a model. And these are things you're going to find in this product and not in the open source community and no other products that I've ever seen. So they're really, really important for creating a model that's useful and accurate and not having to iterate too many times on building models. Let's take a look at the next thing. Training. This is the part of the process where we need the most data science knowledge, although this product, thankfully, doesn't need any real data science knowledge, not after you start really using it. What does training even mean? What is this? Well, in order to use a model, you need to train the model. You got to train it how to recognize items in these pictures, objects, whatever. So in order to do that, you need to feed it data. Now, there are a lot of advanced ways of training models and lots of different buzzwords and things I could throw at you with TensorFlow and Caffe and PyTorch and scikit-learn and blah, 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 blah. But suffice it to say that the tool allows you to pick the best way to train models and to get the results that you need, including some of the more advanced things that a lot of data scientists like to use, like hyperparameter optimization and core ML, which is a way to do edge inference on iOS devices, things like that. And if you don't understand what that means, totally fine. You really don't need to know all that much, thankfully, with visual inspection. Now, when we typically get together with customers, we spend a little bit more time discussing these concepts just so they have a taste of what they could do or what they're about. But we certainly don't dive into them to the level of a significant data scientist background or something like that. So training is an easy thing to do with this. It does take quite a bit of time, especially if you're on hardware that's not up to the task. But that's part of our value proposition, is to size an environment for you to do your training, whether it's in the cloud or locally. And a lot of stuff we do is local just because of the speed of which these inferences need to happen and the amount of data that it takes to train a model. So training, very important part of the process. And then finally, we need to deploy our model to use. The process of deploying the model is pretty simple, really. Number one, we're going to validate the model and score it, make sure that the user understands what kind of accuracy the model can possibly have. So that's an important part. And then we deploy it onto a piece of hardware. We could deploy the model on the same Maximo Visual Inspection server and use resources there, providing a REST API to programming staff or programmers to call to do inference workloads on images or video. So that's a very popular one. Typically, your visual inspection server is the most beefy server you're going to have in the environment to do AI. So it's a great one to run these inferences on. However, it's probably a little bit more expensive to run it on the server itself. So a lot of folks do this. What they do is we export the model and we run it on either another server with maybe not as beefy hardware, but still very capable, or we do the edge inferencing using either Raspberry Pis or other small compute devices, and my very, very favorite, the Maximo Visual Inspection mobile application for iOS. I'll show you what this looks like in a bit of time here. It's a beautiful way of getting started very quickly and getting your project off the ground with really outwriting any code. Unbelievable. This is what the application looks like, the Maximo Visual Inspection mobile. These are the 5 or 6 things that it can do, right? Capturing images, auto capture, and handheld mode, which means it just continually captures those images and uploads them to the server. The inferences at the edge, of course, or it could send the same video and images back to the Maximo server for inferencing on a larger machine. Gives you a dashboard so you can understand what you've done, what's right, what's wrong. And of course, it integrates with external tools like MQTT and Twilio, stuff like that. One of my favorite parts about this application is it has the ability of uploading any captured images back to the visual inspection server. So now I can categorize and continue to train new models based on all of the images I capture in the field from my day-to-day operation, which is incredibly powerful. I mean, these little niceties that they throw into this product are so valuable when creating and massaging and trying to explain models. It really makes things much more valuable, really, to the enterprise because of this. And again, this all happens without any code, right? So that's a very important part to keep in mind. Key benefits to the edge, right? A lot of folks talk about edge computing like this is some new thing, right? It happens on an iPhone, it happens on a Raspberry Pi, it happens onto a small server next to the workload that is being generated, right? Or the inferencing. That's all edge computing is. It's computing or deriving value from your computing environment out where you're manufacturing something. So instead of having the inferencing happening in a data center back on your Maximo Visual Inspection server, it happens on these edge devices, again, such as an iOS device. And again, this product can do that very easily by exporting models to the iPhone or other small computing devices. And another key benefit. So that's visual inspection in a nutshell. I've shown you use cases of how to use visual inspection and where it's most useful to derive lots of value and cost savings and enhance products. I've showed you how to do it with the various tools, the visual inspection tool and the iPhone tool. And I've also showed you the business benefits, the various business benefits of the tool and why you'd want to do it. Okay, so how do we get started on a visual inspection solution? Well, I'm glad you asked that question. Let's talk about that. Typically, most customers that we talk to, we would like to do a discovery workshop. Now, with COVID times here, that probably means WebEx or Zoom call or whatnot over the internet for a few hours. It doesn't have to be a whole day, right? And we're looking for two things when we do these workshops, really. We're looking to see what your use case is and where you think it is most beneficial for you. And with that, we can do a proof of concept, a POC, or MVP, a minimally viable product. So depending on where you are in your use and your understanding of visual AI, we'll pick one of these two things or both things. So the proof of concept, we would typically bring in 1 or 2 or 3 cameras, usually on an iOS device, and start snapping up pictures and data. And proof of concepts that we do are usually free, depending on how detailed and intense they are, just to show the customer, you customers, what to do and how this stuff will work. So we take that data that comes off these cameras, we show you how to make and bake and shake a couple of models, and then how you derive value from those models, typically, again, using those iOS devices and maybe some very, very small custom programming. So that's a proof of concept. The minimally viable product goes the next step. Really, really the next step is, and it is exactly what it sounds like, in something like 8 to 16 weeks, maybe even shorter than that, we're able to bring in a team of folks to design a small product that does exactly what it's supposed to do in a very minimal fashion, right? To start deriving value from visual AI. So we put in place the whole methodology to train models and capture data and retrain models. We put in the cameras where they're supposed to go, whether they're custom cameras run by Raspberry Pis or other custom cameras with feeds going back to the visual inspection server. We put in the storage that is needed to capture all this data that we're capturing from your assembly line. And then, of course, we're putting the inference and results part of the infrastructure up there too. And that's really your first step to deriving power from that. Once that MVP is done, the business will clearly be able to see what kind of value this brought, if anything. And the if anything is, there's a zero chance that there is nothing. I'll tell you that much. It's going to work really well. That's how we typically start with customers, one of these two things. And if you'd like to do that with us today, IBM, Qualix, and MAPSYS, please, you see my phone number, you see my email, give me a call. We can certainly start or chat about your particular use case. But before that, let me show you what the tool can do. That's my next slide, because now it's time for something you'll really enjoy. Who can tell me what reference that is from, right? I'm going to briefly show you how this all works. And I'm going to start with Visual Inspector and go onto the iPhone application, the Maximo iPhone application, and show you how that works. All right, let's take a look. That's my next slide, because now it's time for something you'll really enjoy. Who can tell me what reference that is from, right? I'm going to briefly show you how this all works. And I'm going to start with Visual Inspector and go onto the iPhone application, the Maximo iPhone application, and show you how that works. All right, let's take a look. All right, did we make it all over here? Can you all see this? Man, I hope so. Hope you all made it.
So this is the login screen for IBM Visual Insights. All right, I know a lot of you are already thinking is that I thought we were talking about Maximo Visual Inspection. Well, this is the previous version of the software with the previous name, IBM Visual Insights. We're just going to use this. This is what I have available. The name changed, and so did the new version, the 1.3 version drop, just about 6 weeks ago or something like that. So this is fairly recent. It's going to look the same. It's going to work the same. So let's log in. After the install, which will work on any power-based machine or x86-based machine with an NVIDIA Pascal GPU or later, so that's real important to understand, right? Although I would say you should probably use data center type hardware. Otherwise, it's going to be, man, this is a very nice piece of software. It's a Ferrari of software. You do not want to run it on a $2,000 gaming machine, as it's basically running on in this demo, because my very, very expensive IBM AC922 is being used by actual data scientists back at the office. So I'm relegated to this demo box. So it's what it is. Let's log in. The username is admin for the defaults, and the password, being IBM software, is password with a 0, PASSW0RD. Again, very easy to add new users with a single command line to add any amount of users you want. So here are the 4 tenets in this first screen of how this piece of software works. Again, you've already seen some of this in my presentation, but this is how you use it every day. Create your data set, you prepare your data, probably spend a lot of time doing that. You train your model, which will use a lot of computational resources, and then you deploy your model to do inferencing and actually use your model. Let's get started. I'm gonna click on the Get Started. All right, now, unfortunately for you guys, I do not have a really great manufacturing data set to show you. And the reason why is because all the manufacturers that I work with have proprietary data that aren't too keen on letting other folks see what they're doing. It's, it's part of their secret sauce, and I get it. I agree. You shouldn't be showing people your secret sauce. So I'll be showing you folks my secret sauce. So I made a very trivial demo involving my family members, right? I had a bunch of iPhone images that I was able to upload. And I'm just doing image classification on those uploaded images. So you'll pick out my son, my daughter, my wife, that kind of a thing. So let's take a look. First thing you can do is create a data set. Very easy. One thing I love about this software package is that it's very fast. Test demo. Let's try demo. Bam, done. I created my data set. Here's my test demo data set. I can click it, and then I can drag and drop a zip file, or of course the individual images, as many as I dare put in here, which is important. There's nothing in this particular one, so let's look at something that I have already imported data. How about this one, Aug Singley. So I click on this one, and it brings in all my images that I use. Now there's lots of different things to do here, and lots of different things to show you. There could be images and video here. I could do auto label, though I'm not going to do any auto labeling, although I did do auto labeling at one point. I'm going to certainly do lots of augmentations. I'm not going to show you that right now. And then I'm going to show you the objects that I look for. This is admittedly way too many. So of all these giant amounts of pictures, I labeled all these people here. These are all the different labels. So let me show you how I do that. I'm going to click on a single image. Bam. All right. Either this was auto labeled or I did it myself. I don't remember. I don't recall. That's my daughter Daney and my son Declan and their cousins. So isn't that cute? I could add more labels by clicking this, and let's just say I want to add another label. Say label, add label. Let's just call it. Gosh, I don't know. There's nothing left really to label in the picture. How about the crumbs? This is very trivial. It doesn't even work. The crumbs on the poor baby's front here. So I could use a box like you see here to draw, or I could use a polygon. Polygon will be definitely much more accurate. I can draw my little polygon here of where the crumbs are on his chin. So there you go. There's a new label. It's very trivial, and it's not going to do very well, I think, when I train my model. But you can see it. So after I do my labeling, of a few images, what I could do is I could then train a model or partially train a model, because that would help me then auto label. So what this means is I can select a model. I have two models deployed right here, so I could select either one, and then I could adjust my confidence level, whatever it happens to be, and then bam, hit auto label. I'm not going to do that now because I've already labeled a lot of these images and I don't need to do that. What will happen is it will go out there and auto label the images, and then you can review all the auto labels. It'll clearly delineate which is an auto label and which is a label that you did yourself, and you can edit them and augment them and whatever you want to do, correct them, if you will. So that's auto label. Export data set. I just spent all this time getting the data set in. I don't want it back, but I can certainly get it back if I need it. And then augment data. This is how I can add different colors or whatnot to the data sets, to rotate the images, add noise, flip horizontal. It's a really incredible way of making more data out of your data, right? To make your models more accurate. Very, very important feature. If you were to do all this, incidentally, folks, by yourself, as you certainly can using open source technologies, right? This would take you just forever. It would just, we're talking weeks and weeks and weeks and weeks just to get this far, okay? And I can just do this practically in an hour, get as far as you've seen here. Now, of course, there's, none of these people are on the assembly line, but, they could be, right? So anyway, that's preparing your data, importing your data, and curating your data, and preparing your data. I'll leave it at that, but this particular stage, a lot of folks really do spend a lot of time in making sure their data sets are clean and pure and good, and they have the domain knowledge worker sitting here categorizing defects for minutes or hours on end. Maybe they do it once a week for a year, that kind of thing, to really create the best data set you possibly can to train your model. After all, your model's only as good as your data that you feed it, right? You're teaching it. It's like a child, right? You're teaching it how to recognize images, right? So that's what you're doing. All right. So after you've done all this, let's just say I did everything good and I'm ready to train my first model, or retrain a model that I use to do auto labeling. I'm gonna click on my train model here. All right, so now I can name my model, of course, and then I pick what kind of thing I'm doing here. Image classification, right? And then that could be a good one. Using these optimization models, right? Here's the system default, the system default rather, GoogleNet, or I can do this custom packaged model, which I don't have access to right now. I could also look at the advanced settings of all this stuff. So here's much more data sciencey type things, right? Iterations, testing, learning rates, that kind of stuff. I can certainly do all of that if I need to, if you understand what that is. I can enable Core ML, which is really good because then I can do my inferencing on edge devices, which again, very, very good, very useful. Object detection is what we typically do in a lot of these examples, right? And I have lots of different optimizations and models that I can choose from here, and there's various reasons why you'd want to pick each one, and that gives you a little description of each one as well. Here again, Tiny YOLO V2, I could do the Core ML model, which I can export to an iOS device and continue to do that way. And then of course action detection, right? And it's exactly what it looks like. It's going to detect some kind of action over various series of pictures and that kind of thing, or video. So that's good. I'm not going to click on train model right now. It would take me a long time. I do want to point out at the upper right hand corner, you do have this GPU usage here. It says 0 is available. If I click here, it tells me what they're used for. The 1 is used for deployed models. None are used for training. So that means I have something deployed. I only have one GPU in this particular system. Most systems are going to be between 4 and 8 GPUs. And if I have a cluster of these things, it could be, it could be more of that kind of a usage model. So let's go now take a look at my models. These are all my models that I've trained that are available for deployment. I marked with this one production. Is it? I don't know, but I can come over here and click it. Can't deploy it because I have to undeploy a model first before I can deploy it. So there's always that. But you can kind of see the accuracy is okay. It's getting up there for sure. My loss versus iteration, right? And a lot of this stuff, data scientists can really tell you much, much more about it all, and what these things do. And we certainly do when we do a engagement. Most of your staff members will be much more versed in this stuff once they see it from our guys. And again, man, we show you all sorts of different parameters here. I'm not a data scientist, although I'm close enough for this call. And so, some very useful metrics here. Okay, I could also export the model. If I click on this, you'll see it starts a download here. Hopefully once it packages up the model on the server and then sends it over to me, and I'll be able to take that download and put it on edge devices or other servers or whatever. I do need you see it started over here, Singley, right? Here comes the model. I do need a small, very, very inexpensive license file to use a model that has been created on this software package on another device. So it shouldn't be a big deal. But I do want to mention that's very inexpensive, a few $100s. That's it. A couple hundred. All right, I have no custom assets in this particular stuff. I'm in the demo. I'm not going to really talk about that. Here are my deployed models. Okay, I'm going to show you a couple of things here real quick. These are the 2 deployed models. I can very easily click them and then say undeploy. Right, bam. Now you'll see that there are 2 models have been undeployed, and that my GPU usage should be. Should come back to me here. It still says 0 available. I'm sure it's just a matter of seconds until this becomes available, and you're going to see 1 GPU available now. If I go back to models, let me show you again one more. How about I click on this model and I say I want to deploy it. I have a couple options. I could do GPU or CPU. Depending what you're doing, what kind of heavy lifting, maybe a CPU deployment is okay. There's plenty of CPUs in a lot of these systems. The one I'm on right now, although the one I'm on right now doesn't have very many CPUs, maybe 8. But the typical one I use at work, and a lot of the stuff that we do is run on a Power Systems AC922. It's the same node that the largest supercomputers in the United States were built on, Summit and Sierra systems. And they have lots of CPUs per node. I think ours has 40 CPUs, so that could be a good choice. So if I click on CPU, and then I can click on deploy, and bam, you see that it's being deployed right now. Deploy is in progress, okay? And now it's deployed and ready for use. Incidentally, if I go up here, you can see 1 GPU is available. Now I can deploy a model on one of the GPUs. So that's it in a nutshell. There's one other thing, and that is projects, and I could categorize all of the assets that I put into this software, including the models that are built, into a project. So I can very easily understand what part of the assembly line I'm building models for. Okay, and then I'll be able to come back and go through different projects and work on that stuff depending on what I'm doing. I think it's also really important to note that you just don't build one model once and you're done. You're supposed to be building think of it like a pipeline, a methodology of building models, collecting new data, retraining your models, and redeploying them so that the models get better and better and better as your manufacturing process continues. All right, you're not going to be building the same widgets forever, at least most manufacturing lines don't, although some do. So that's an important point. As you're buying this package, a software package with services, which are the people that help train your teams to understand how to put a methodology together to identify where you want to have AI vision applications in your manufacturing process, to collect the data, to build the models, to utilize the models, to inference on those models, to derive some value from this process. And then you gotta refeed the pipeline again. Refeed the pipeline with more data, new data that you collect, new failure modes, retrain those models, get those models deployed again, and do the same thing over again. It's a constant iteration process. And that's the thing I think that a lot of folks out there just don't quite get yet. It's this AI stuff is still sort of in this academic mindset. Well, we're trying to put it in this production mindset now, and that's how we have to use it. So that's really it for a very, very simple taste of Maximo Visual Inspection. Let's take a look at the Maximo Visual application on iPhone, okay, and see how that works. This is just my iPhone. It could be on any iOS device. So this is my iPhone sitting right next to me here. Hope you can see that too. I think you can. It's up on the screen, right? I have a couple inspections that I have on here based on the models that you saw in this project. I am going to bring up, let's see, this one here. The reason I'm doing that is I'm not going to use my terrible models that were rushed into production and made very hastily because they come up with silly results. Sometimes they label me as my son. Sometimes my son's labeled as me, and that kind of thing. It's kind of funny, but it doesn't get across to you how good this software can be during different times. So in order to use the software package, it's very, very simple. I'm going to take you through that right now. So I'm going to click this little gear icon at the top corner there. And the only thing you need to do is come down to the bottom and put your base URL in with your username and your password. That base URL is your Maximo Visual Inspection server with a /API at the end. Okay, and that'll get you 95% of everything you want to do. And you can create inspections and do everything and et cetera, et cetera. I'm not going to do that today. I'm going to use the demo mode because it's just really easy and it's going to be simple, and the models are trained very, very well in this demo mode. So in this demo mode, we're going to look at these. They have two different demos here. I'm just going to do the first one here. Bam. Going to click on that, and there's lots of different things you can do with this, folks. You can use this iPhone app or iPad app to sit on a custom mount and take videos or pictures as various manufacturing production events happen, or on a time period, or whatever, or manual. Let's just do a manual right here. I have up on my screen an Arduino Uno, so I'm going to click on capture. So let's take a look here. I'm just going to look right there, get close enough, and bam, took a picture. And it's telling me that with 99.94% confidence, that is an Arduino Uno. Again, a little bit of a trivial example, but it shows you how good this model was trained. And this model and the inferencing on this model happened on this device. Doing various things on this device. Let's cancel out of here. Doing various things on this device, you could actually ship the models back, or not the models back, the images back to the Maximo Visual Inspection server to have the inferencing happen on that server, depending on how complicated and what you're actually trying to do. With that, there's a dashboard to tell you all sorts of things about the failure rates and the pass rates, or how many photos you looked at and collected photos, etc. And down here, it would show you examples of the photos. I'm not sure why they're not loading in the demo mode, but they're not. And then all these photos, which I think is really, really important for your workflow, you can set it to send all the photos back to the visual inspection server, or save it to your camera roll here for later export, which is really, really key, folks. You got to understand, you got to continue to collect data as you use AI vision in your manufacturing processes. If you just collect a little bit of data and don't continue to improve your models, quickly, I feel, and I think most folks feel, that they will become useless over time as things change. Okay, so very important. This iPhone app does this for me without me having to do anything, right? Nothing. I don't have to write any code. I just have to type in a few things like where my server is, and off I go. And that's the basis of our proof of concept, for sure, without bringing in fancy cameras and all sorts of things. But it also provides something I think that's very unique too in the industry, and that is it provides immediate feedback to those domain workers sitting on the line actually doing the work, and to see what the inspection came up with, right? Whether it runs on the device itself or back to the main server. So real quickly, that was our Maximo app. It's on the App Store, free download. No Android support yet. I thought it was going to come, but just not yet. Okay. So with that, I am going to go back to my presentation here. And I want to say thanks. Thanks to all you folks out there. I know this was fast. It was like drinking from a fire hose. I get it. I said a lot of things here. I didn't say a lot of things about other things. But listen, I'm always around. I love talking about this stuff, and I love helping customers. You see my email there. You see my phone number. Love to help you out. We have a very extensive knowledge base and depth and breadth on this. Not only can we help you with the software, we can help you with the services to get it up, and especially the infrastructure to make sure you're going to be successful with this. Some of this stuff requires an awful lot of hardware to be successful, a very big, heavy lift. And we can set you up in, I think, some really, really good ways to do that. Our company specifically specializes in high-performance computing in academic settings. So we talk to lots of various large universities, including some very, very, very well-known ones. I won't say their names, to help them get their high-performance computing and their AI projects off the ground and be successful. So a wise sage once said, that's me maybe, AI-guided visual inspection, right? The wise sage once said, the organizations that use AI in their manufacturing processes will have the definite advantage. And that is true. All organizations that manufacture any widget out there will be using AI eventually. And the ones that jump on board sooner will have more of an advantage than the ones that jump on board later. And that is just simple fact. I hope you folks out there are the ones that jump on board sooner. I'm certainly here with lots of experience to help you out with all that. Thanks for your time today, folks. I really appreciate it. Maybe I'll be speaking with some of you in the near future here. We have more webinars coming up with other varying topics such as this, and even more advanced topics that use AI in this exact same software. Hope you'll tune into those, and I appreciate your time today. Back to you, Keith. Take care, folks.